Network security. Network security is today's a large subject. How to prevent and protect our network. Today are using more infrastructures in networking items, mobile items, and more things, wireless, wire, like this. How we protect our network to the we are using internet to the internet network. How to protect our network? Discuss today. Firewall. Firewall is a protecting host by restricting network connection. Allow to transfer good packet, block to the bad packet. Design prevent malicious packet from entering. Basically, firewall perform packet filtering. Firewall basically prevent our network to the malicious packet. Like this is our LAN connect to the internet outside network. Some internet outside network, global network come from to the packet tower LAN. How it filter? We can use firewall to the filter our packet. And some hackers try to hack our LAN before we are using the firewall. Firewall is checked by who is come to our network. Right? Protect, first prevent, and after protect our network. This is very important. Firewall has normally two parts: internal side and external side. External side is global side. External. This is the internal side our network LAN. We can protect using the firewall our network. Firewall. You can see this is the internet. Internet is sent to the packet to our network. Right? If we need that packet is good packet, we can forward to the our LAN, or this is packet is bad, we can drop the packet without transfer the our LAN to the checking to the packet. Firewalls basically has two parts: software-based firewall and hardware-based firewall. Run as the local program to protect one computer, personal firewall, or as a program on a separate computer to protect the network. We can protect our LAN machines to one by one using to the software firewall and hardware firewall. Separate device that protect the entire network firewall. Normally software firewall, for example, personal firewalls and Windows firewall. There is only all the computers we can install personal firewalls like Windows firewall. Software firewall, how is understand, how to identify software firewall or hardware. Software firewall is installed on the platform. Platforming is the or Linux or like this OS. If we need to install plus OS, in the OS we can install some firewall that is called software firewall, like Windows firewall, other small third-party firewalls also there. ISA firewall, like others. I think open source also has firewalls. And hardware firewall. Hardware separate device that protect the entire network. Protect the entire network, like the network firewalls, like a sonic wall. And hardware firewall is a like this OS, operating system. If we can install to the device like OS, it is like OS. And this like normal Sonic call it has Sonic call router, Sonic call it has Sonic call OS. It is installed by the device. And very famous open source file there. Normally we State also use pfSense. pfSense. You can download internet also. pfSense, pfSense, pfSense. It's also firewall. It can install personal PC like a OS. Just install like OS. After, if we have knowledge, we can configure pfSense firewall. It's called hardware firewall. It's installed by the hardware. Software firewall is installed by the platform. To the platform we can install. This is a difference software firewall and hardware firewall. Intrusion detection system. Intrusion detection system means examine the activity on the network. It is examine the activity. Who are the come from outside to the our network. If packet is checked and this packet is bad, is drop given to the report for the IDP. Goals is detect intrusion and take action. Get the detect the intrusion. Who are the come from outside? Detect is good. Forward to the land. Bad. You want to the report to the intrusion prevent system. Two type of intrusion detecting systems there are: host-based IDS and network-based IDS. Install on server or other computer. IDS are installed on the computer, server or other device. Monitoring traffic. If we can monitor the traffic and from the particular computer, we can monitor traffic. What data, what packet is come. UDP packet, ICMP packet, TCP packet, like this. We can check. TCP, UDP, right? We can check what packet is come. And we can monitor also. And locate behind the firewall and monitoring all the network traffic, network-based firewall. Locate behind the firewall. We can locate the behind the firewalls, right? The firewall after LAN, like this. Our LAN after our router, after internet site, right? Like this. Network firewall. This is behind the firewall and monitor all the traffic. We can monitor all the traffic come from our network. Intrusion preventing system. Unlike IDS and IPS, is able to actively block prevent intrusion. It means IPS take an action. Infection and investigation. Infection can include signature-based infections and statically anomaly-based infection investigation. Includes analyzing sophisticated packet and activity. Action. Once unwelcome packet are identified, IPS would either them in quarantine or simple drop them. Log can report. Like many security devices, IPS can log, attack and send the report. Like this, some packet is come to the here, right? IDS check, detect the packet. IDS is a detect the packet. After this packet is good, for packet good or bad, forward IDS to here. After IDS given to the idea, this packet good or bad. After this packet is good, IPS sent to the firewall, sent to our LAN, right? If the some packet is come, this is a bad packet, right? Come, IDS given to the report or error message or alarm to the IPS. right? IPS to the IPS. After IPS, this packet is sent to the IPS. IPS, this packet is back given to the IDS given by the IDS information. Error message. IPS drop the packet. Never sent to the avalanche side. Never sent to the avalanche side. Right? This is a concept of the IDS and IPS. Normally, the IPS and IDS are same one item, right? With together stabilized to the firewall. Same item, but I show you this image to the I understand you, right? IDS same hardware part in the firewall, right? But this is a concept. IDS is check the packet, detect the packet, and given to the idea. Error message or alarm like a report. After IPS, get this packet and packet is according to the IDS idea, send to the packet to drop the packet and send to the report for a send. Network address translation. NAT is the translation of the IP address used to within one network to a different IP address known within another network. IP address used to within one network to a different IP addresses. Different IP address known within another network. LAN to WAN or WAN to LAN. Network address NAT system hide the IP address of network devices. Hide the IP address. Some IP addresses are hide. So for example, public IP hide to the other global part and map to the local IP. Located just behind the firewall. Located just behind the firewall. Like this is a firewall function part, NAT. Right? Firewall function. NAT device use and allies IP addresses in place of the sending machines real one. You cannot attack what you can see. Right? Somebody try to attack, can't attack. Why? They don't know the IP address. Why IP address is sometimes hides. Network administrator create a NAT table. Network administrators, they are create a NAT table to configure the routers. Router configure. They can configure router NAT configuration and after create a NAT table or NAT box. And that does not go global. That does the go global or local. Global to local and or local to global IP address mapping. We can forward to the global to local or local to global. Four type of NAT there are: static NAT, dynamic NAT, port address translation, and port forwarding. Static NAT, dynamic NAT. Now I explain static NAT. For example, this is our LAN, right? This is our LAN, right? This is a router or firewall router, right? It has NAT configuration. This is our WAN site, right? Internet. This is the WAN site, right? This is the WAN site. This is a LAN site, right? This is a LAN site, LAN, right? Local area network, our network, our private network, right? In normally this site has public IP, right? On public IP, for example, 192.248, right? 211.35, like this, right? This is our public IP, right? Providing to ISP providers. We need to pay and we can get the IP address, public IP. This is our LAN. LAN IP address 192.168.1.0.24, right? You can host 2 pipe host, right? Like this. we have public IP. To configure the NAT in this router, this public IP map to this network. That means some packet come to this public IP, or the packet map to this net, right? This is a NAT config. Sometimes can map to this network, or sometimes map to the one IP, local IP address, right? Or one or more IP address. Sometimes four, right? Static IP, static NAT is, right? For example, we have this is a we have right we have this is a web server, right? Web server, web server, web server, right? After this is the FTP server, right? FTP server, FTP server, and we have other servers like mail server, right? Mail server, mail server, right? It here connect to switch, so switch to the connect to the like this, right? It is IP address is 192.168.1.1. So IP address 192.168.1.100. Mail address 192.168.1.24. 254, right? Like this. This means if we have 3 servers, somebody try to access our web server, right? This means we need to use 3 public IPs, 192.168.248, right? 211.36 and 211.37, like this. 192.248, 211, 37, 36, and 35, like this. Static net means one global IP, one public IP, one public IP mapped to the one local IP address. This is a static IP. Other local IP address, other global IP address mapped to the other local IP address. Right? Other global IP address, public IP address mapped to the other local address. Right? That is a static net. Right? So somebody try to access our web server. Like this is our Slayer web server, slayer.ac.lk. Slayer.ac.lk. Right? Somebody, this domain has one public IP. This public IP, somebody access to the our slayer.ac.lk website to come to this static IP. Read to this static IP. After our netbox, net table, configure here this router configure, right? Configure net table to the net table, read, map, transfer to this data to the web server. Somebody send to the my mail at chintaka@ac.lk, right? chintaka@ac.lk, sd@ac.lk to send to the mail to me. So this mail packet come to the here and ac.lk mail server sent by at c@ac.lk send to the read this IP address, public IP address, and send to the mail server. After mail server distribute to the mail to the our mailbox, right? Like this. This is a static net, right? After dynamic NAT. What is dynamic NAT? Same like this. We have, this is our LAN, right? This IP address is a 192.168.1.024. That means it has 254 host, right? It means our LAN has more computers. I think 200 computers there in our LAN, right? Like this. After router, NAT router firewall, netbox, it has netbox, right? After internet. Right? We have one public IP address, 192, right? 208, 111, 47 like this, right? IP address. This is a public IP address. Here is configure, net configuration, dynamic net configuration. That public IP map to this network, right? Map to this network. Some packet is come to this IP address, to the internet, to the globally WAN side. Come to the packet this side, to this IP address, forward to this LAN, right? If we have the LAN like this, right? Not forward to this LAN, not forward this LAN, only forward to this LAN to the net command. This is called dynamic NAT, right? Dynamic NAT. After, third one is port address translation. Port address translation. For example, right, this is our LAN, right? It has a right mail server, like a web server, right? Web server and FTP server, FTP server, FTP server, and mail server, mail server. Mail server, right? Web server is a IP address 192.168.1.100, right? Port is 80, right? And FTP server 25 port, right? Sorry, 21 port, 21, and the mail server is mail server port number is 25. Like this. IP address is 192.168.1.1. Mail server 192.168.1.254, right? After this is our router, right? Connect to the here, and it's our WAN side, right? It's our WAN side. Global IP is 192.168.1 dot, sorry, 101.35. That is not a public IP, but 2 point, sorry, 2 point, right? This is a public IP, right? So public IP, and right after, here's a mail server IP address, web server mail address, local IP address, and port number. Right. This is a web server local IP address and web server port. Right. It is that is mapped to the this public IP address and port number 8002 is port number, right? And it also and FTP server 192.168.1.1 port number is 21. Right? IP address and port number which together map to the same public IP 192.168.1.248. Sorry, 248. 101 35 47 8003. Right? 803. This IP address and port number map to the this public same public IP different port number 8003 like this. And this is a mail server. This IP address map to the this IP address and 8004 port number, right? Like this. After mail server, web server send some packet to the outside through the this port IP address sent to this port sent by the this IP address, same public IP address, but different port. This traffic only going to the this part. FTP server is going to send to the packet in local site to the global, going to the this part. This is a port address translation. Port address and within each host on the LAN is translated to the router WAN side. Public IP address within different port assignment, different port assignment, right? Port numbers are used to map traffic from specified host on the network. Specify host on the network. Specify host going to the traffic network, right? The table mapping of internet IP addresses and port numbers to the translation IP addresses and port numbers are enabled performing tracking of the packet in and out. Packet in and out. PAT can handle many internet hosts with single public IP address. You can see. Port can handle many internet hosts with the single public IP address. Many internal hosts. Many internal hosts we can handle using port and same public IP, different port number. Different port number. This is a port address translation. After port forwarding. Port forwarding. Port forwarding is this is our LAN, right? This is our LAN. Right? This is our LAN. Also, it has I think web server, right? Web server, and FTP server, like this FTP server, right? This is our router, net box, right? Switch, connect to the like this. After this is the internet, WAN site, right? I think web server port is 80 and FTP is a 21 port number, right? It is IP address is 192.168.1.1, 192.168.1.1, right? So 192.168.1.100 like this. Port number is 80 now. Port number 80. Map with the use the IP address and port. Port forwarding is port number 21. Right? Right? It has one global IP address. 220, right? 247, 211, 36. Like this public IP. This public IP map to the different local IP using different port, right? Right? Port forwarding, right? This IP address, public IP address, right? Public IP address map to the web server, local IP address and port, and this IP address map to the FTP server, local IP address and port. This called port forward, right? If some packet is come to the web server, right? Same path, right? This IP address read after this packet is come to the web server with web port 80880 and read and forward to the web server. One packet comes to the FTP, read by the port 21 after this IP address 100 is part the same, right? This is a port forward, but normally the same way come to some packet come to same way, but packet come to the same way, but traffic is divided by the part and sent to the here, right? But normally in industrial using to the this means one public IP map to the difference local IP address, difference local IP address, one special difference IP address, right? One IP public IP address map to the difference special IP addresses in local IP addresses using port number. But this is a problem for the traffic. No, the more busy time, the more users are use the web server and FTP server. This has more traffic. No? This means both industrials are using to the static NAT. Why? One public IP map to the one local IP address. This means quickly can transfer data. I think one public IP 220, 247, 211, 36, that IP address map to the web server. After 220, 245, 211, 37, other public IP map to the FTP server. Other public IP 220, 247, 211, 38 like this. Public IP map to the mail server like this. Static NAT. This is a good, but we need to spend more money to get the public IP. Why? ISP providers are providing to a public IP to the us, but we need to pay to them. Internet service providers are providing to the public IP, but we need to pay them. This is more expensive. This means we can use. We have no more businesses. We can use like this port forwarding, right? To configure the our network. But this is a way NAT is one one IP range mapped to the other IP range, or SAP, right? SAP concept. SAP into the other pair. SAP. Sorry. Right? SAP. SAP to the WAN side to the SAP to the WAN side. LAN side. Right? LAN side to SAP to the WAN side like this. Global to local or local to the global. This is a NAT basic things, right? If you have knowledge, you can configure router, right? NAT configuration after you can use. And firewalls now today firewalls also has NAT configuration, right? We can configure NAT configuration using to the firewall also. Firewall also has NAT facility, right? Proxy server. Proxy server is a very important thing, and proxies are also firewall, very good firewall, right? Server firewall is this is the internet, right? This is the internet. It has this is a global site. It, I think has one public IP 192.248, right? 211.49, like this, right? This public IP assigned to the one network card, right? This is our LAN side connect to the other network card, right? After proxy is that public IP set to the local IP. After we can transfer to data to the LAN, right? Data to LAN. This is a proxy does, right? Proxy is working like this, like a gateway, like a gateway, like a gateway. It has more gateway, like a gateway, right? Like a gateway, right? Net route also like a gateway. It's working like a gateway to the one side sap to the other side, one side map to the other side, like a routing concept, net configuration, like a net, right? Like a net, right? We can use the proxy. No, we can block the Facebook like website. No, Facebook like a social website we can block, social website we can block, and word we can block like a sex word. Somebody type to the sex word in our line using internet. We can block this word using the proxy. Or we can block torrents like this. We can block some packet, right? We can block ICMP packet. We can block ICMP packet. Right? ICMP packet. We can proxy as some Denny or allow. Denny, we can Denny something. We can allow something. Right? We can allow some packet. We can give some IP ranges. This ranges come some packet. We can allow to the LAN like this. We can configure. Proxy server is a server act as an intermediary for request from the client seeking resources from the other server. The client connect to the proxy server requesting some server, some service. No, proxy server requesting some service like HTTP service, right? Like HTTP service, like HTTP service, or web page, or other resources available from the different server, and it evaluate the request as a way to simply and control the complexity. An advantage of the proxy server is that cache can serve all users of one or more internet site are frequently requested. These are like to be in the proxy cache, which will improve user response time. The cache proxy cache servers are both universities are now using cache server, right? This is our lab, right? Right, you can think this is our computer lab, right? This is our computer lab. It has I think 200 machines like this. I guess I know that, right? You can think our land is that 200 machines, and this is our proxy cache server, proxy server cache, right? Cache server. But I simply getting some picture, right? Given to idea only, right? Technique, right? You can see the some students, right? Some students come and view the some video, some topics, suitable topic. He try to view the video, YouTube video, right? He download this machine and see this video. The cache server, this video save the cache server, save this hard disk, this video. After this video name is A, right? A is a save in cache also, right? After other students come and view other video, like a B video, right? Right? It has, I think, 1.5 GB, right? B video is a 1.5 GB, like this, right? Two students are coming computer lab and view some videos to the according to him some subject topics. B video also save in the cache. After other 100 students are come to the computer lab, they also try to access the same video to the internet, right? To the internet, a video. But if we have cache server, right? Cache server has this video. No? If we have access to the internet, but we don't know, we think we are getting this the video internet, but cache server provide this video to us. Cache server provide this video to us. All the students to provide this video, all the machines, a video. Not lose our data, right? We can without lost data we can use, right? Now not use the internet. Cache server provide this video to us. This means we can uh, we can without the loss of internet data we can use same video. Normally all the universities or institutes students are using same video. Different students are using same. We try to view the same video. This means cache service provide. This is the advantage. More advantage. I'm typing a video is using 1.5 GB, no, using 100 student, 150 GB is loss. We are not using cache server. If the cache server we are using, no, only use 1.5 GB only. Others, no, others GBs are 148.5 GBs are we have now, right? No loss, no data. This is a very advantage. Both universities are now using this cache server, but our institution not use. We need to configure proxy cache server, right? Virtual private network, a secure network connection over the public network. Allow multiple users to access, right? Allow to multiple user access information. It's step to unique sequence connection called tunnel. It's used to the, we can access VPN to the tunnel. For example, this is a VPN, right? VPN means we have LAN, right? We have LAN, right? We have 100 computers. We have 100 computers, our LAN, right? This is our LAN. We had 100 computers like 192, right? 168, 1.0, 24 netmarks. We can host, we can do 254 machine, we can host. We have 200 machine like this. We have 200 machine, right? After our head of shared head office. Shared head office has VPN server, VPN. Shared office has 300 machine, right? Shared head office has 300 machine, right? And it and also VPN connection also there, VPN server also there. For example, VPN server there, right? It is a network is 192, 168, 4.0 subnet mask, network mask 22, right? 255, 252.0 subnet, right? We can use more than 900 machines. 900, we can think that we need to connect 900 computers like this. We can use this subnet, this IP address, right? Now we are trying to connect to the VPN terminal, connect to the Slayer VPN server. It's a VPN server, right? Connect to the VPN server, right? To the internet. To the internet. Seattle also has internet. We have also internet. To the internet, We need to internet to the internet using to the VPN server. We are connected to this VPN server. If we connect to the VPN server, our network, virtual private network, this is our network IP range. But if we connect to the VPN, say at head office VPN, our LAN also convert to this IP range automatically. Now we are also the 192.168.4.0 range. Now we also the convert to the automatically. If we are connect to the VPN, our network also connect to the shared head office network. Shared head office network. This means now we and our LAN and shared head office also same network. This means we can access. Here is a database server. Here is a mail server. We can connect. No problem. We can connect to the locally mail server and web server without any restriction. We can use. Why we are in the now same. This is a virtual private network. If we connect to the VPN, other network, automatically we are converted to this network, right? This is after we can use database server. For example, bank, right? Bank, no, Ampara branch and Kalamu branch and Matara branch and Kandy branch, right? And Jaffna branch, all are connect to the VPN tunnel, right? All are connected to the VPN tunnel, right? This all the network is same network. Now all the network is connected to the VPN, all the network is same network. This means if we have database server, head office Colombo has also database server, we can communicate very easy to, right? If we update something, if somebody come and create new account, all the this account information, all the servers to come and replicate. Database replication configuration should be done after automatically same network, automatically replicate to the same information all the bank. This means it has separate network, but if you are connected to the VPN, means same, convert the same network, connect the same network. That is a advantage, right? If we after they can access directly via database server. All the information replicate to the, if you column something update there, this information update to the all the bank, right? This is a VPN concept. And you know, I think last year IS attack Sahara to Sri Lanka, right? That time Facebook is blocked in Sri Lanka. Facebook blocked. Somebody is connected to this is I think New Zealand. I think foreign country, one of the foreign country VPN, right? Somebody go to the Facebook, connect to the other country VPN. If they connect now Sri Lanka network, they can't in the Sri Lanka they can't go to the in Sri Lanka network. Anybody can't go to the Facebook. After they are somebody connect to the foreign country VPN. Now that machine come from to the like a foreign country, not physically, logically is going to the foreign country network, the same network. Now this machine, now that machine not in the Sri Lankan network. This convert to the foreign country network. Now they can access the Facebook. You see, that country never block Facebook. But problem is you are providing your username, password, everything are connected to this VPN. After they have everything, they can do anyone your machine. This is a problem. Your personal data, if you have very important data, they can view, they can attack, they can hack. This is not a good, but somebody connect like this. This is a concept of the VPN. You can say this is a VPN tunnel. to connect to the gateway, LDAP server, open source server, right? VPN site, right? Gateway, and remote client. Remote users, I think you are in the home, right? If you are in the home, like in both the industrial person, private sectors person, no? If they live in office after some problem there, they can connect to the VPN server and configure something to, by they are connect to the VPN after they are say, like a same network. After they can access all the servers to the seeing the remotely in home, but they connect to the VPN after like this. He are sitting like in company. After some errors there, they can configure. They can give a solution, right? Today is both software developers and network administrators. They are using this. They configure VPN server, VPN server in them company. After some username and password providing VPN server to the using this VPN username password, they are remotely access to the them LAN, internal private network, and access to the uh, computers server database like this. What is the firewall? A checkpoint of control and monitoring interconnected network with different trust. Firewall is a control and monitor. We can control, we can monitor, right? Firewall has monitor facilities. Firewall can control the packets. Interconnected network with different trust, LAN and WAN. Impose restriction on network service. And also firewalls restrictions on network services. Only authorized traffic is allowed. Only authorized traffic is allowed. We can give a permission to allow or deny. No? This packet allow. Like TCP IP packet allow. ICMP packet drop like this. So if we can give some IP ranges, one of the IP ranges come to some like we have other branch, right? Other branch there. That side someday packets come. That packet we can allow to our network, right? Like this. Auditing and control access. We can audit it. We have monitoring now. In this mean we can audit our packet and we can control access. We can control the access using to the access list configuration. Can implement alarm from abnormal behaviors. We can use also alarm concept like I think intrusion prevent system, no? Intrusion detection system providing to the alarm, no? Providing alarm to what the bad packet come. Intrusion detection system provide to the alarm for the intrusion prevent system. Like this means after intrusion prevent system drop the packet. Providing NAT and usage monitoring. Yes. Also, firewall has NAT configuration. That means one side packet public IP address packet forward to the local IP address, local site. Implementing VPN using IPsec. Implementing also the VPN virtual private network using IP security, right? IP security must be immune to iterations. Firewall limitation cannot protect from attack by passing it. Cannot protect from attack by passing. Attack by passing cannot protect it. Snaker net, utility models, trusted organization, trust service, SSL. SSL means secure support layer to the configuring HTTP or DNS service. HTTPS secure support layer to transfer to the some web server to the some service to the our site like eBay. We are going to use the eBay something like that is not given to the facility, not block, no, not given to limitation. This is not can't give to solve. Also SSH means remote access in open source. If we can access the remotely our servers, we are in the home. We can use the using SSH. We can connect the remotely our servers. But firewalls not block these things. Without firewall restriction, we can connect to the SSH. Cannot protect again internal threat. Cannot protect internal threat, right? That can't protect to the internal threat. Sometimes somebody put some pen drives, it's viruses there. Firewall's not going to protect that. Cannot protect against transfer to all viruses, infected program to all files. Also, viruses not protect. Firewalls are protect to the unwanted packet. Somebody hackers try to come to the our side. That packet is unwanted packet drop to the firewall. But viruses are not given to the block because hug range of OS and file type. Why? Very hug range. No? Firewalls, faculty filtering, simplest, fastest firewall component, foundation of any firewall system. Examine each IP packet on context and permit or any according to the rules, right? If we can decide what are the rules, right? Using firewall, we can write a firewall rules, right? According to the rules, firewalls are work, right? Firewalls is work. Why? If we can block some packet, right? I think, for example, if we need to block FTP server, FTP packet, right? We can block using FTP packet, right? We can give a Denny FTP packet, right? Denny FTP packet. After somebody try to access FTP server, firewall is blocked. Hence, restrict access to the service port. We can also block the port. For example, if we need to block 8080 port, right? We can block, right? Somebody try to access to the 8080 inside to outside, they can access. So outside some try to come to the some port to the some 25 port FTP, right? They can't come to the inside the network, right? Possible default policies that not expressly permitted is prohibited, right? Sometimes not prohibited to the come to the inside the network. Firewall faculty filtering, right? And you know, I think faculty filtering mean in OSI reference model 7 layers there, no? 7 layers there. In, data link, physical layer, data link layer, and network layer, right? Physical layer, understanding bit encapsulation to the segment encapsulation to the packet. Third layer is understanding packet, no? Packet means IP addresses, right? Packet, right? Third layer is understanding second encapsulation transfer to data transfer packet, right? Third layer, network layer, understanding IP address, right? This means packet filter, right? It means third layer concept, right? Third layer concept, packet filter firewall is third layer concept, right? This means TCP and UDP are the understand TCP and UDP, right? It's a diagram protocol, right? This is a private network, packet filtering router, right? Internet, come some packet, no? Some unwanted person come to the inside here, right? That packet is unwanted packet is checked by the firewall after drop. So some packet is good into the private network. You can see firewall packet filtering. Some this is a firewall GUI configuration there now, right? Block will allow there, right? We can block our host, right? All the host we can block. SPG, SPIG out, right? We don't trust these people. Somebody come this SPIG out site, right? Like this packet come, they can't come our inside it. Allow our GW 25 being web server. Web server is right. It's a simple mail transfer protocol like S25 is mail server. Mail server data is not blocked, allowed to the our network. Simple mail transfer protocol like this. Block, default port is a block, and allow 25 port again connect to the SMTP port, and also this also allow 25, and acknowledgement and some request block, right, and allow and block like this. If we can configure like this using GUI. Attack on packet filter, action layer. Attack on packet filter. IP address is spoofing. Fake source address to be trust, and filter on the router to block, right? Router to block. Somebody try to attack to the IP address is spoofing, right? Somebody try to attack our network. Somebody try to attack our network, right? This is not good packet. Fake source address to be restricted. Source address to be restricted, right? And source address restricted. Somebody try to come our firewall, no, unwanted packet. IP address also restricted. Add filter to router to block. We can add to filter and router to block. Source routing attack. Source routing attack set the router other than default, right? If we have like this, right? This is a default router, default gateway, right? Default gateway. Normally, if we have router, we normally assign by here. It's a default router, default gateway, right? Default gateway, right? Default gateway. Somebody hackers, right? Somebody hackers connect to the router and put to the IP address default gateway our router IP address, right? Put to the right. Put to the IP address him machine default gateway our IP router IP address. After he try to hack, come to the inside. This means firewall block to the all the source packet, all the packet block to the some packet come to the router to the firewall, all the packet are blocked. All the packet are blocked. Thin fragment attack. Thin fragment, tiny fragment attack. Tiny fragment. What a fragment mean? You know, the fragment is part, no? Part. So the one of the data is right. One of the packet is come to the router, right? Right. Somebody try to attack. Attacker try to attack our inside the lane, right? Time to time. Time to time try to attack our. Just time after for example, he try to attack our LAN. Put the password. Try to put the password, right? He try to type password wrong. After just 5 minutes or 2 minutes going, after again try to the put the type to the password again. Okay, some time is going. This means after that, this is after that packet is read to the firewall and block like this, right? This is our packet. Packet size is 400, right? Packet size is 400, right? Packet size is 400, right? This is a header. Header size is 20 byte in 3980. No, like that. This is like our packet size. After divide by the fragment, 3 part or 2 part, we can divide our packet like this. 2020. Header is 20. After header is 20, we can divide by the fragment, right? Divide by the fragment. And attacker send to the packet part by part, right? Part by part. Attacker send to the packet part by part, right? But that packet not suitable our format, right? This means firewall is a block like this, right? Firewall is a block. Why this packet is not the correct packet? Attacker don't know. Attacker don't know why our packet is divided by part, no? Right? Attacker send to the packet large packet, right? But our packet, our firewalls is read by our packet segment by segment, right? That means attacker don't know. Attacker send to the packet full packet. This means firewall no. This is not our packet. Why? Our packet is divided by the part by part. 400 divided by 3 type header 20 like this. We can give like 200, 300, right? 200, 300. After other remaining part put here like this. After calculate, we can get this packet size, right? But attacker don't know no, how is understanding our firewall, right? After he try to attack our network full packet, but firewall understanding like this after drop the packet, right? This is a concept. Firewall stack full packet filter. Traditionally, packet filter do not examine higher layer context. Traditionally, packet filter do not examine firewall. Traditionally, packet filter, right? Packet filter is a, I explained before, packet filter is a third layer. No, packet is understand third layer, no? Network layer, data link layer, physical layer, data link layer, network layer, right? And transport layer, transport layer, transport, right? That's the reason packet filter firewall is called also stateless firewall. Stateless firewall. Why it is read by the third layer, network layer, right? Understanding packet, IP addresses, and like this. But transport layer is understanding sessions, right? That this call is stateful, right? Fourth layer, transport layer, right? We also call stateful packet filter mean transport layer packet filter like this call, right? It is under read by the session by session mean the come some message come from some server, right? 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 Time and our LAN, firewall, right? This is a firewall. Is come to some session. What session come? Right? What time is come? Session is understanding. Session. I think like directly not come to the packet. No, somebody send to packet after other packet come. No, like this. No? This means transport line. Read the session and understand. This means stateful packet filter. It machine return packet with the outgoing flow. Right? Stateful packet filter address this need. Right? Address also this need. They examine each packet, each IP packet in context. Each packet context. Source IP address and destination IP address, right? Like this. For the source one, for the destination one, or the destination MAC address, right? Contents is read. Keep the track of client server session. Client server session. Like example, I said. So no server requested the client. Our site requested some web server, right? Session. What time come to this session? Check each packet validity belong to the one. Hence, are better able to detect bugs packet out of the context. You can detect the bugs, right? Somebody send to some bugs, no, we can detect. Firewall, application level gateway firewall. Application level gateway means application layer. This last layer in OS reference level, 7 layer, application layer, right? 7 layer. It is read by HTTP, no, HTTP, yes, all the protocols like DNS, domain names are telnet, right? Telnet. All the protocols are understanding application layer. Has full access to protocol. Has full access. All the protocols can access. Right? Specific gateway, proxy. Proxy also the application level gateway. Right? Application layer understand. Then action request and return result to the user. Request. And they have monitoring and auditing concept. They can return to the result. Can log, also log report also. Log entry we can also configure. Log entry. What IP address, what IP address come from to the inside. What IP address, what machine, what local IP, local machine going to the outside access, what type of website access, right? We can check all the things using the log file log audit traffic, right? Some service naturally support proxy, other are more problematic. You can see, you know, right? In the telnet we can block through the using application gateway protocol. Why somebody try to connect, outside person come try to connect to the telnet, they can't connect. Why we can block using the application gateway telnet, right? Telnet, right? For example, FTP also we can, SMTP, HTTP like allow, right? Eh, handshake protocol, handshake protocol to the client and server, no? Client and server, right? Clients request to the server, server response, client send to the hello packet to the server, server send to the hello packet to the client. After communication, okay, after again server can send to the certificate, right? Server can send to the certificate, server can send to the key, right? After server can send to the authentication. After this over finish, right? After client also can send to the client also can send to the him certificate and him key and check authentication is correct, communication done, right? Like this. If the after this also this authentication and this authentication same, no, process is okay. After can communicate to the way of client and server. Firewall circuit level gateway, really two TCP IP connection, really two TCP IP connection there, right? TCP IP connection. Impose security by limit which such connections are allowed. Impose security by limiting which such connections are allowed. Once create usually really traffic without examining the context. Typically used when trust internal security by allowing general outbound connection. SOCKS is commonly used, right? Normally two TCP/IP connection. One is a global, other is a local. To the SAP to the global to local like this. You can see, right? Inside the connection to the mapping to the basting host. Basting host is the server software, right? This is also given to the facility to protect our network. This is a good software, good firewall in basting host to prevent and protect our network. Highly secure host system. This is a very highly secure system. Run circuit application two ways there: circuit level gateway and application level gateway. It provides externally accessible service, potential exposed to hostile element, hence is secure to withstand this. Harder in OS essential service extra audit for privacy small, secure, independent and non-privileged. May support two or more net connection. It is support to the two or more connection, internet connection, right? If we have vast and host firewall, right? It can connect to ISP providers internet line, right? And after we can configure. One line is sometime broke, not work. We can allow to the other line. This means redundancy. We can use redundancy, no dedication, right? Redundancy. Maybe trust the enforce policies, trust separate between this net connection. Firewall configurations, faculty router. You can see this is not a good network, no? In firewall faculty router is there, internet can't, no? After faculty router, only directly can access, no? Booster router. Just come to the booster router, fasting router, right? After going to the data. not secure. It's also good, no? Right? It come to the data in here after send to the here, other way, right? It's also very good, no? To inside route also there, outside also router there, right? Internet come after lasting host configure the configuration. That's all. Thank you for listening.